Hello everyone, my name is Shahab, and in this video we want to talk about how we could test our code analyzers. In the previous episode we have written a code analyzer that analyzes a misuse of a maybe type, and now we want to write tests for it because if we don't do that it would be disappointing. So let's dig into it. So in the previous episode we saw that we created a maybe semantic analyzer that we're analyzing our code, and in under some circumstances it was reporting a diagnostic, and it was in here that after we are checking whether there is a maybe type as a return type of a method, and then within that method there is a throw statement, then we were creating a diagnostic report and we were reporting that to the context and compiler. Now we want to create a unit test for that to make sure that first, further refactorings will not break the system. And second, we have a place that we could go there and see what's the specification of this analyzer and what we should expect from it, right? So let's do that. First of all, I'm going to create a new project and I will name it sample.analyzer.tests. And I am going to use XUnit as my testing framework. Feel free to use NUnit or MSTest if you're more familiar with that one, and use those frameworks. There shouldn't be that much difference between them. So let's create the project in here. So the first thing that we need to do is reference the project that we are going to test. So I'm adding a project reference here, and then I need to manage NuGet packages. The NuGet package that we need to add is microsoft.codeanalysis.c#.analyzer.testing.xunit, because I'm using XUnit as the framework. So you could use NUnit if you are using the NUnit, and you could use the MSTest version if you are using MSTest. And I'm adding the latest version 1.12 to my project, sample analyzer tests. So our first test will check against methods that have the return type of maybe and throwing an exception within that. So let's put a fact in here, and then it would be public void when method returns maybe. The first thing for the implementation is to have a string that represents a source code, and that is the state of the application when the analyzer is going to be run. So let's do that first. Using sample.fx is where my namespace exists, and we also need to a reference to system namespace. Then we need a public class program. Let's have a method in here, public maybe of a string, a method. And there in here we just have no, that's not what I wanted. Throw new invalid operation exception. So this is our application. What we expect is that we expect that this line there is a diagnostic reported. So this is our expectation. Let's do that. The first thing that we need is we need to create something that we could define the state of our application, the test state, and then we could also specify what is our expectations after running this analyzer on our system. To do that, we need certain classes, and they are provided by this NuGet package that we added. And those classes are provided for us within this NuGet package that we added to our application. To do so, I need a C# analyzer test. So I'm creating an analyzer test, and it is of type new C# analyzer test. And it accepts an analyzer and a verifier as a type argument. So this is my maybe semantic analyzer. And there is a couple of verifiers. What we are going to use is default verifier. Previously in version 1.1.1, there was like XUnit verifier or NUnit verifier or MSTest verifier. They are obsolete now, and you should use the default verifier. So as properties to this one, there is one which is describing the test state. In the test state, we have several properties. The first one is the sources, the source codes that we want to be part of this. The next thing that we need is the additional references. And as we learned in the first session, we could do that by using the metadata reference that create from file. And here we could pass type of non.assembly.location. And here, since it doesn't know it, we could reference the project that this one exists in. The next thing is to add reference assemblies. This is the assemblies that we need like as a runtime. So we are saying which SDK we are going to use. It has a lot of properties in here. We have the default, we have net, we have net core, we have net framework, which is .NET framework, the classic one, .NET Standard, and here we are using the .NET, and since I'm on .NET 9 version, then it would be .NET 9 that we are adding here. The last thing is the expected diagnostics in here. So we are passing a list of diagnostics that are expected to be reported after this test analyzer is running. To create these expected diagnostics, we could leverage C# Analyzer Verifier class. It is another helper class provided by this test NuGet package that we added. And it provides us with a bunch of factory methods that we could use them to create the diagnostic that we are expecting. So let's create our expected diagnostic. Our expected diagnostic equals C# Analyzer Verifier. And then we could pass our analyzer in here and the diagnostic that is expected. I think I have one extra in here. And then we could have the diagnostic. This diagnostic, we could pass the ID of our diagnostic and then the location that we expect this diagnostic to be reported in our source file in here. So we have our source file in here, right? And what we are expecting is to have a diagnostic reported exactly at this location. And that means it is line 1, 2, 3, 4, 5, 6, 7, and 8. And the number of columns, which which is like from here to here, it is either 8 or 9. Let's see how many columns do we have in there. So I'm going to say 8 and 9 for now, and that is our expected diagnostic that we want to pass in here. So this is our test that we are creating. The last thing is to just run that analyzer and mark our method with a task in here and async, so it could be running. Let's run the unit test that we have. And it passes. That means that our behavior, what we implemented, is correct. So let's go in our analyzer itself and change something. For example, let's not report anything in here and we just ignore everything, right? Now, if I run my test, it should be failing because we are expecting one diagnostic, but nothing is reported. So here you see there is a mismatch between the expected diagnostics and the actual that are reported, and the test is failing. Let's minimize this page. Let's revert the changes in our analyzer, and that should be it. So another test case that we could create is that if there is no through statements in the method, then no diagnostics should be reported. This could be like another one. So let's duplicate this test case that we have in here. So let's here just saying it return maybe of none, right? And then we don't expect any diagnostic, so we could also remove this part. So I'm going to run all of the tests again. Everything is green. That means our code analyzer is working as we expecting, and we have some specification defined to prove the behavior of our analyzer. If you're interested, you could add more tests to this specification and make sure that the analyzer is adapted to what you are expecting. So in this episode, we learned how we could add unit tests to our code analyzers and how we could verify whether our code analyzer is reporting the diagnostics that it should report at the exact location that we are expecting those errors or warnings to appear. And if also nothing should be reported, we could verify against that. I appreciate if you like this video, you subscribe to the channel and also share it with your friends. The source code for this whole series also will be available in GitHub, and you could find the links down below in the descriptions. As always, enjoy coding and devam et